Hey, what's going on everyone? Adam the Tutor here, coming at you with another Laplace transform video. This one's a little bit easier because it's already in exponential form. So with that being said, let's just get right to it here. Okay, so we're going to have the Laplace transform of e to the plus minus a times t is going to be equal to the integral from t is equal to 0 to t goes to infinity. And then we're going to have of e to the plus minus at e to the minus st and then dt. Right? And at this point, basically, all you got to do is just combine the two exponentials here, and you're going to get e, and I'm going to take out a minus s. So if I take out a minus sign, that's going to be a minus plus a times t dt. Now, at this point, basically, what you can do is you can recognize, oh, okay, hey, I know that the Laplace transform is basically a function of s, right? And I can kind of, just explicitly write this one here, right? Because, I mean, it is there. You're just writing it out, right? So, basically what this would correspond to is, so the Laplace transform, let me just kind of explicitly do this, because I think it'll be easier if I do it that way. The Laplace transform is a function f of s, and normally it's denoted by this capital letter, right? But now, now I'm taking the definition of the Laplace transform and I'm shifting it by this minus plus a, right? So what you can kind of see is that if I were to carry this integration through, right, and let's just go ahead and do that, what you're going to see, though, is that if I have Laplace transform of e to the plus minus at times f of t, what you're going to see is that this is equivalent to the Laplace transform of f of s minus plus a, right? So multiplication of this f of t by this exponential will shift the Laplace transform of this function in this way. So let's go ahead and see that, right? So basically here, our f of t is equal to 1, right? So let's go ahead and see what I'm talking about here. So we got 1. Okay, so when we integrate this, and actually I don't need to write this integral again because I'm already just going to integrate the exponential there. This is going to be equal to e to the minus s minus plus a times t, and that's going to be over minus s minus plus a, right? And this is from t is equal to 0 to t goes off to infinity. So now what we're supposing is we're gonna suppose that s minus plus a is a positive quantity. So basically, a must be less than s for the minus sign case, right? So what we're going to get is the following. So when we evaluate this at t goes off to infinity, this guy becomes 0, right? Then we have a minus, but this minus cancels with this minus, becomes plus, and we'll have t is equal to 0 here, so this exponential will basically be 0, and we'll have a 1 plus, minus plus a, right? So we have that the Laplace transform of e to the plus minus at times 1 is equal to 1 over s minus plus a. And if we compare that to just the regular old Laplace transform of 1 over s, we can see that this guy right here is shifted to become this guy right here, right? And a consequence of this is this guy right here. So, despite the fact that all we were interested in was just originally this Laplace transform of A, what we now have is we have our first shifting theorem. Right? And there's actually two shifting theorems. I'm not sure if this is, referred to as the first or if the other one is the first. But this basically gives a relationship between shifts in what is known as the frequency domain or S domain and the corresponding shift in the time domain, right? So that's basically really all there is to say about this. And so if you have any questions or comments or anything like that, just drop them in the comment section below, and I'll do my best to address those questions and all that good stuff. So, again, thanks for watching, and I will see you in the next video.